Hi guys, welcome back to another video. This is Codeforces Round 869 and the problem is almost increasing subsequence. So let's quickly see what the problem states. The problem setter states that you have a sequence which is called as almost increasing only if it does not contain three consecutive elements x, y, z such that x greater than or equal to y greater than or equal to z should not exist. What does it mean? Let's say for example you have 1, 2, 3, 4, 5. This is almost increasing because everything is lesser than the previous element. What if it is 1, 2, 3, 4 and 3 here? There is one deviation, but that's fine. XYZ is not satisfied here, so this is also almost increasing. But what if it's 1, 2, 3, 4, 3, 3? Here 4 is greater than or equal to 3 and 3 is also greater than or equal to 3, right? This condition comes here. So if this condition comes, this is not an almost increasing subsequence. That's all. So these are all valid. If any set of integers is satisfying the condition, then it's almost increasing subsequence. This condition should not come. They are telling that you will be given a set of integers like a1 to an and q queries will be given. Each query will be of the format of L to R. L to R represents the subarray. You have to find the longest almost increasing subsequence. Now for those of you who don't know, there is a difference between subarray and subsequence. If I say subarray from 3 to 5, I am telling the continuous set of numbers. If I tell the subsequence, let's say from subsequence from 2 to 5, 2, 3, 4, 5 is a subsequence. If I remove 4, 2, 3, 5 is a subsequence. That is after removal, and if I am maintaining the order, then it's called a subsequence. In subarray, you can't remove any number. In subarray means a continuous set of numbers. Subsequence means also continuous set, but you can remove those numbers. So what did they ask is, they will give you two numbers. You have to find the longest almost increasing subsequence. After removing certain numbers also, were you able to find the longest increasing or almost increasing subsequence? So here in this case, I can remove this. If I remove this, the longest almost subsequence from 1 to last number is 1, 2, 3, 4, 3. So that's the thing. And to understand this, let's quickly glance through this example, that is 1, 2, 4, 3, 3, 5, 6, 2, 1. So for simplicity, I'll just use the 1 based indexing here. Okay. Now from 1 to 3, 1 to 3, it's almost increasing, right? That's how you got 3. 1 to 4, this is also almost increasing because 4 is greater than 3. When it should not come, x greater than y equal to greater than x greater than y, or y greater than or equal and y greater than or equal to z comes, then it is not possible. You should remove one number. Now 2 to 5, this is 2, 3, 4, 5. This is 3 greater than or equal to 3. This is not possible. So you are forced to remove at least one number. So the longest increasing subsequence can be 2, 4, 3 or 2, 4, 3 or 2, 4, 3 or 2, 3, 3, anything. So that's how you got 3 here. What if it is 6? To check the condition, we need 3 numbers, but they told only one number. From 6 to 6, there is only one. So obviously you can write 1. 3 to 7. So from 3 to 7, that is 4, 3, 3. This is less, this is also less. So we already know that out of this is not satisfying. So we need to remove one number here, and 4, 3, 5, 6 is valid. So 4 numbers are there here. Now let's go for 1 to 8. You can try for 1 to 8. 1 to 8, what it comes? 6 is greater than 2, but this is not, there are no 3 numbers that is satisfying the condition, but we already know that there are 3 numbers that is satisfying the condition. So we'll remove one of this. After removing one of this, there will be 7 numbers that is remaining. So that's how you get 7. So whenever you get a question like this, where they are giving you a number and using queries, you need to get the answer in big of 1 or big of L. Before that, the one thing that comes to our mind is to do brute force, right? If we get L and R, okay, we go for L, we go for R, we try for all the combinations XYZ, XYZ, XYZ. Whenever it's not there, we remove one element. That won't work because the computation will be too high. So whenever you get a question like this, make sure you pre-compute the array. You should know some formula to compute the array, and whenever you get this, you should get the solution in big of log n or big of 1. Whenever I tell 2 to 5, I should do some calculation and tell that okay, there are this much number, there are 4 numbers between the array such that this condition will be satisfied, almost increasing will be satisfied. I should not go ahead and do the computation. So prefix sum, everyone might know, right? 1, 2, 3, 4, 5, if it exists, what will be the sum? 1 plus 2 is 3, 1, 2, 3, what is the sum? 6, 10, 15. Suppose if I want to find the sum between 2, 3, 4, What is the sum? 4, 5, 6, 7, 8, 9. This is the naive way. I add all these numbers. But if I am asking in 1 second, like from 2 to 4, what is the sum means? I can take the sum 10 minus this. 10 minus 1 is 9. Similarly, for I want to know the sum from 3 to 5. I don't want to add all of these numbers. I can just take the 5th element and I can just take the L minus 1th element, that is this, and remove this. 15 minus 3 is how much? That is 12. So 3 plus 4 is 7, 7 plus 5 is also 12. So we should do something like this to get the answer. How are we going to do this? So as you see, we also have an editorial that is published. So I am using the same solution as a explanation here. So if you want, you can go ahead and read it. So let's see. What I'm doing is, how am I pre-computing the arrays? It's a modified version of like DP only. So you will be noting down how many downhills have happened, how many deviations have happened in the array. So as you see here, for one time we got from 2 to 5 also we computed, for 4 greater than 3 greater than or equal to 3, and for 3 to 7 also we computed this value, and for 1 to 8 also we got this. So what if we know that in 3 to 5 there always existed? So how are we going to do it? Let's do it in this way. So what we do is, first we want to know how do we iterate through it, how do we prepare for it. That is x greater than y greater than z means the condition should always be from I equal to 1 to n minus 2. Do you agree with that? Because if this is I minus 1, then this is I plus 1. I hope I make sense here. So what should be the downhill value? So if you see, the downhill value will be, for simplicity let me keep as d, that is v of I minus 1, x is greater than or equal to x, and this condition also should be satisfied. That is what is y here, v of I is greater than or equal to v of I plus 1. If this condition happens, then there definitely exists a deviation in the array. So if there exists a deviation, this will be true or false. So in integer terms, this is 1 or 0, right? Now you compute the array called as dp or p something. Now whenever you find a deviation, you add it to the previous element. As I told earlier, we are just doing something like a prefix 1. So whenever a deviation comes, we keep on adding to the previous number. So let's say 1 is here. 1 is the first number, we don't have to do anything. 2, 1 is less than 2, it is fine. Now 2 is less than 4, that is also fine. 4 is greater than 3, okay, this is satisfied. Sorry, 2 is less than 4, this is false, so again 0 here. So let me write the same here, that is 1 2 4 3 3 5 6 2 1. For 1 you got, 2 you got, 4 you got. Now 3 comes here. 4 is greater than 3, right? True. And 3 is greater than or equal to 3, that is also true. So d comes here, and the previous element I am adding 1 to it, it becomes 1. Now again this 3 comes, 3 is greater than or equal to 3, this is true. And 3 is less than 5, this is false, right? 1 and false. True and false is always false. So 1 plus 0, 1 plus 0 is 1. Now again 5 comes here, 3 is less than 5, 5 is less than 6, these both conditions are not satisfied. So again you put 0. So it is 1, 1, 1, similarly and so on. So you got it, right? From this point the deviation happens. So whenever they are asking, if they are asking me two numbers, let's say for example 2 to 5. So 2, 3, 4, 5, I can say that there exists, I can just remove what? This number, that is a of, first thing that I have to do is, we get 2 to 5. First thing that I need to do is, I need to know the total number of elements in the array. Total number of elements is 5 minus 2 plus 1. There are 4 elements, right? How did I get 5 minus 2 plus 1 means 2, 3, 4, 5. 4 elements are present in the array. Out of this, I have to subtract the number of deviations or downhill moments. How many downhill moments are there? As I told earlier in the sum example, I need to reduce the number. Where should I reduce? That is, I need to go for 4 because that is the y value. The y value I need to reduce from a of 4, that is this 1 minus this L value. So 1 minus 1 is how much? 4 minus 1 is 3. So we are logically telling that out of the 4 elements, I found 1 deviation and I am removing that deviation from the subsequence, and I got 3 as the longest increasing subsequence from the array. Now what if it is 1 to 8? 1 to 8 means it will go till here, right? Now what do? I go for there are 8 elements in the array and I need to reduce the number of deviations. How am I reducing the number of deviations? It is the subtraction of what? Subtraction of a of r minus 1, that is this one, that is 1 minus that is dp of l, that is the lowest bound. So this one means number of deviations from 1 to 6 minus number of deviations till 1. Okay, so how much? This is 0 here, 1 minus, so this will be 8 minus 1 plus 0, 8 minus 1 is 7. So there are 7 numbers, so that's how you got 7. So again I'll tell you, like for simplicity, what do? We take the set of numbers from L to R, we take the total count between L to R, that is R minus L plus 1 gives the total number of elements in the array, minus from 0 to R how many deviations are there. That deviation you'll get in dp of R minus 1, because we are taking the y value here, minus dp of L. I am excluding these values from the array. So from this one to this I get the number of deviations here. I am removing this. If I remove this, what do I get? Minus, if I remove the brackets it will be plus. So by this you get that from the total number I am removing only the deviations, so I get the longest increasing subsequence. So this is the same as this tutorial solution. So this is the blog entry here. They have given you a beautiful editorial also. You can please go through this and try to understand. I try to simplify it. Now I'll explain this solution. I tried on my editor and it's working as well. So what did they say? First they took all the numbers in the array, that is the set of numbers. Then what they did, from I equal to 1 to I equal to n minus 1, they counted the deviations. That's what they call downhill, and they are computing the downhills, that is from 1 to n how many deviations are there, that is in summation 1 plus 2 plus 3 like that, right? Number of deviations till from 1 to n. Now they are getting the queries here, L minus minus R minus minus, they did for 0 indexing, and if both of the numbers are equal it is 1. And again what we are doing here, in order to know the total number of elements in longest increasing subsequence, I need to get the total number of elements in R minus L plus 1 minus, this is P of R minus 1 plus P of L, that is they are eliminate from 1 to R, they are getting all the deviations minus 1 to L, this subtraction they get. So L to R they'll get number of deviations. So total number of elements minus total number of deviations, that is downhills, will give you the answer. So I hope this gave you some idea. Please do work it on your own, or if you have any doubts please ask in the comments. I'll try to help. Thank you.